Hello again. So this is a video for extension 2, and it's actually, it might be interesting if you're doing extension 1, but you don't need this for the syllabus. So integration by parts. So we've talked a lot about excuse me, the reverse chain rule, and I'm sure that many occasions people have said, oh, what about a reverse product rule? Well, that's what integration by parts is. So I'm going to start by writing down the formula for integration by parts, and I'm going to write it down with u's and v's. So uv dashed equals uv dashed, sorry, sometimes the unresponsiveness hurts me, uv dashed plus vu dash, right? So take the derivative of one, leave it alone, take the derivative of the other one, leave the other one alone. Okay, that's how we differentiate with the product rule. So to integrate with the product rule, basically what we're going to do is we're going to integrate both sides. But essentially we will never, the problem is that we won't have this as the thing we're asked to integrate. We'll have this or this. And, I mean, that was a terrible explanation, but just bear with me for a minute. So what we're going to say is that uv dash dx equals the integral of uv dash minus vu dash, sorry, dx. Come on, there we go. Alright, now what that actually means is, alright, this bit here is the integral of a derivative, so we just get back to where we started, and this thing here we can't do anything with, so you leave it like that. So the way you read this is, I've got a product of two things, and one of them I can integrate, namely v dash. So I start by integrating that, and I leave the other one alone. It just stays as u. And because I can differentiate everything, I then do u dash. I can always differentiate u dash, and I leave v alone. And there's a minus sign there. Right? I'm going to show you a quick example, and it's an example that we've talked about a couple of times, which is the integral of log. And this is actually interesting because it doesn't look at all like the thing I just showed you, which is uv dash dx. And I think I used the same letters, but the point is the letters actually mean nothing. As long as you remember to integrate one, differentiate the other one, you're fine every time. Now, the problem is that this one has only one thing. So how could it possibly have a u and a v dash? Well, the answer is that you can always generate your own v dash by making it 1 times. So I'm going to call v dash 1 and u log x. So this is going to become log x times the integral of 1, so x, minus, so I've integrated the x, so I leave it alone, and I haven't done anything to the log, so I differentiate it. And I'll just move down to here. So then I get x log x minus the integral of 1. And so that's x log x minus x plus constant. Okay? And I can show you how to do a bunch of different things, but I'm not going to do those in this video. But basically there's quite a few different strategies that we'll develop for doing this. Maybe I'll show you one very quickly. So let's say, for example, I asked you to integrate x to the power of 4 sine x dx. Now, I need one of these two things to be u and one of them to be v dash. Right? Now, normally the thing you pick for v dash is the thing you can integrate, because often you can't integrate the other one. But I actually can integrate them both, so I could pick either. And I'm going to purposely make the wrong choice. So I'm going to pick x to the power of 4, and I'm going to integrate it. And so I get that. Sorry, it's getting messy because it's a bit small. Oops. Okay, and now the point is that this is basically further away from what I want it to be, because the power of x has gone up, right? So I'm going to need to use parts again because I've got a product of two things that are unrelated. And really what I'm trying to do is I'm trying to get rid of all the x's, because if I can get rid of all the x's at the end, I'll just have like integral of sine, or I'll have integral of cos. Either way I can do it, right? So that is the wrong thing to do there, right? So I should actually have integrated sine here and made it cos, and then left the x to the 4 alone. And then the next step, I'll do some rubbing out, and I'll write that again. So I should have integrated sine, and then the next step is I differentiate x to the power of 4. Right? Now this is getting closer to just 1, and so I made the right choice. This would actually take me quite a while. I'd have to do like 4 more lines of work, right? But the point is that you're heading in the right direction every time. Okay, it's getting a bit long, so I'm going to stop there. But I just wanted to show you the formula before Tuesday, and also get you thinking about strategizing how you might do it. So you might like to try, for example, and integrate. What could you integrate? X squared log x. Maybe try that. I'm not really sure how hard or easy it'll be. Either way, I'll do it on the board on Tuesday. Hope you're having a nice weekend. I'll see you Tuesday.